What? I'm back? I'm making a video after like 2 days? Man, this is crazy for me, guys. Alright, today we're going to be talking about dealing with animation curves. And to deal with an animation curve, you can do it in Blueprints or C++, but I would highly recommend doing it in Blueprints. It's way easier. But with that being said, I love C++, so I mean, if you like C++, why not do it in C++? It will probably be faster. So I want to show you how to do animation curves the right way in C++ versus doing them the wrong way. So an animation curve, by the way, for anyone that doesn't know, looks something like this. So this one's called float linear 2 seconds. I made this myself. And you can see it just curves upwards and then it curves downwards. And so animation will follow this curve. So say this is the curve that we use to rotate something. You can see it's going to start out rotating quite slowly. It's going to rotate quite slowly. Here it starts to rotate a little bit faster. And then it rotates back down, so it closes the curve. And in this case, if we were to use this to rotate a door open, you can see the door would rotate open and then it would rotate back closed. This axis here is time, so you can see this curve runs for exactly 2 seconds, and it reaches this maximum value of 1, which it should always kind of reach a maximum value of 1. You don't really want to go above that. I mean, you can, but there's not really that much point. I will say there probably are instances where it's useful. Okay, so we will create that. I guess I'll show you guys how to create that now. You want to go into miscellaneous, curve, and then select a curve float. I might go into the other curve types later, but for now we'll cover a float. And I'm going to make this one a float linear 3 second. Now remember, you can call it whatever you like, you don't have to call it float linear. Okay, so since I call it float linear 3 seconds, I'm going to make this one run for 3 seconds. I'm going to hold shift and click, and you can see it adds a little point. I'm going to set the first point to 0, 0. The second point's going to be at 1.5. And then you can see the last point is going to be at 3. And then we'll go 3 and 0. And then to get that nice curve, we're just going to click on the point and then go auto. And there you go, we have a nice curved float linear. So we'll go ahead and save this. And there we go. So anyways, back to how, what's the right way to do the floats and whatnot. So here I've got a door, right? And when I walk into the door, it swings open due to an animation curve, and I can walk back inside as well. And that's one animation, right? That's a door swinging open. But you have to realize that with doing animation curves, there's a lot of different types. We might be rotating the object, we might be scaling the object and making it bigger, we might be moving the object. Those are 3 different things we can do. But then on top of that, are we scaling it in the y-axis or the z-axis, or what axis are we rotating it in? So there's a lot of different types. What you don't want to do is to, say you have a door that swings open, so you write some code that makes a door swing open. And then, you want a sliding door that slides open. So you write some more code that makes the door slide open. And then you want some code that makes an object grow. So you write some more code to make an object grow. And before you know it, you've written, 1,000 lines of animation code. And it's kind of useless. You can't reuse it at all. It's only useful in your particular scenario. So what I have here is what I call the rotatable. This says any object that can be rotated should be a rotatable. And this door, in fact, if I click on it, be rotatable door. So the way this works, right, is you just say, what axis do I want to rotate it on? So you can type in here, roll, and now watch. My rotatable will now do some crazy... There you go, it slides off to the side. Actually, it looks kind of cool. We could also do pitch. If I type in pitch here, you can see that my door is going to do some crazy thing where it like lurches forward. Oh, it went backwards. I bet you it's going to like throw me in the air too. There we go. Oh, I'm such a hacker, guys. Look at, oh my god, I'm such a hacker. I don't know how I do it. Anyway, so like that's the idea of a rotatable, is we just tell the object what axis do you want to rotate it on, and then there's another value somewhere in here. There you go. Max, in this case it's called max bounce height, because I was going off like moving up and down with vectors, but since this is a rotatable, we could just do like 45 for example. And you can see it's not going to come down the full 90 degrees anymore, it's just going to go halfway. As you can see. So that's one thing, that's a rotatable. There's no reason why you couldn't also make shiftable or scalable objects as well. Oh, and there's also a trigger to trigger the door opening, of course. So yeah, that's the whole idea. That makes it a lot easier. So now if I want something... Say I want to make a sliding door. Actually, I can't do that yet because I haven't done a scalable class or a movable class. You know what? Say I want to make a cat door. Yes, you heard me right. Say I want to make a cat door. I'll be right back. I'm gonna just make this up really quick. It'll take like 5 minutes, but I don't want you guys to have to watch me do it. Okay guys, get ready to just be like, wow, that's so cute. Look, I've got a little cat door now. This honestly took me like 3 minutes to make. Now that I've got my rotatable class, I can just make any rotatable object. That's kind of where I'm going with this. But anyways, look at it. Look how cute that is, guys. Honestly. Look, I can go out this door. Oh, I should probably fix that door. But anyways, you know, let's just do it for the sake of fixing it. Set that to 90 degrees. And you can see we have float linear 2 seconds. We could use the 3 second one if we wanted the door to open more slowly, which I'll show you. So like my door, I got my door. I kind of made it open the other way, but that's alright. And then look, my little cute cat, he's got his own door, dudes. Look at that. How sick is that? I wish I could get through it, honestly. I'm pretty jealous of my cat. I probably can. Should we do it, guys? Should we go through the door? The cat door? I think we should. Let's just like mash my character down. Is this gonna work? Come on, guys. Oh my god. Look! I'm the cat! Guys! Oh my god, we're making history here, guys. Look at that. Oh, also that's a 3D interface I was working on. As you can tell, it's not quite finished. Well, there you guys go. There's the power of it right there. You can make your own cat door and not even have to rewrite any code. Anyways, where I'm going with that, right, is that you can just make anything and you can make it really easily, and it's not hard to do at all. Let's make my character back normal size. Anything that rotates, right? I could even set this if I want. If my cat's like a ninja and he can make it out super fast, I can set the animation to go 360. And now my cat door is going to do like some weird 360 spin, right? Oh god. Well, there you go. So, just anything that you would ever want to animate that rotates, we make this rotatable class, rather than you having to write like 72 classes all doing their own animations, which is just totally useless. Anyways, I've talked for way too long, but the actual code's quite easy, so you guys won't find this too hard at all. Alright, well anyways, I guess I'll be back and we'll get started on the code. Rotatable. Anyways, once rotatable comes up, we'll start in the header file because that's basically where you always want to start. Okay, so the first variable that I'm going to have here is the rotation axis. So putting the axis to rotate the mesh on. So also by default, I'm just going to set this to be yaw. So it's always going to spin this way. But obviously you can change that in the editor. Okay, so every rotatable is going to have a mesh. Whether that's the cat door having a little door or the normal door having the big door, it's always going to have like a mesh. So let's put a static mesh in there. So the static mesh for the rotatable. Okay. Also, a rotatable is always going to have a box trigger. I guess not in all cases. You might want to write another class without a box trigger, but in this case, I'm going to assume that every animation is going to be triggered by some sort of box. So in this case, we'll just make the box trigger for the rotatable property. Edit defaults only. Box component. And we'll call it anim trigger. So this is basically the thing that's going to trigger the animation. Right, the next one is the max spin that the rotatable will reach. So the way the curve works, right, is that it just goes up and then back down. But depending on what we set the animation to, imagine my hands are a door, by the way. I know, I'm so creative. Whatever you set the animation to will basically happen. So if I set the rotation to be 180, the door's going to go like that. If I set it to 360, the door's going to come right around. If I set it to 90, the door's going to do that. And so this value here, float max spin, well, we can just call it max rotation. That's the maximum amount it's going to reach. So like if I set that value to 90, we get that. We also want this to be a edit anywhere value. Oh, also, if I sneeze like 70 times, I sincerely apologize to all of you. Oh yes, the last thing we need is actually the animation curve itself. So you remember we made that little curve, the 3-second one. That's the one we're going to use to open and close the door. So we'll just say curve, float, reference. We want this to be edit anywhere so that we can choose what curve float we want to use. And then we can just put this in the same category as the rotation. We'll just say animation. Curve, float, animation, curve. And that's almost it. There's still more. It might seem like this is going to take ages, but the actual code for the project, the rotatable, is actually only 80 lines. And most of that's just like blank space and stuff. It's very, very short. It's probably actually only like 20 lines total. Okay, so we want to add some private values here. Initial rotation, so what is the rotation initially at? So if rotator actor initial rotation target rotation we need an if timeline. If your if timeline does not become recognized, which is really annoying, you will have to put an include up here. And I will tell you guys what the include is, by the way. So just if this doesn't turn a green color, for some reason the header file isn't included, go into the description below and I will include the line that you need, and you just need to put that line there. So just do that and then your code will start working. It should say like if timeline is not defined or something. We need a U function to handle the animation curve. Might seem like we're doing a lot here, but the fact that this is reusable is the real handiness of it all. I would also like to say thank you to oh man, I'm sorry, I can't say your name. Orpheus? Orpheus? I don't know. He has a website, orpheusel.com, where he briefly covers the concept of animation curves. I've kind of modified it, taken it to the next level where it's a lot more reusable. But nonetheless, I did actually learn a lot of the stuff off his website, so that'll be in the description as well. He has a lot of great tutorials. Really like that guy. He's got some good stuff, so definitely go check him out. And then here we just have on animation triggered. And again, I'm not going to make you guys watch me write out all of the parameters because there is just too many. So just pause the video if you have to and just put all those parameters in. And that's the header file. So the header file is almost as long as the CPP. So let's write out the CPP file now. Really easy stuff. We'll start by initializing the mesh. So we're going to say rotatable mesh equals create default subobject use static mesh. Rotatable mesh. Then we're going to make the trigger. We need to tell the trigger to generate overlap events, so we're just going to set B generate overlap events to be true. And then we need to add the delegate for on component begin overlap. So when we say add dynamic, this is a delegate. We're basically saying add a function to the component begin overlap. I could be wrong, but I think you can actually add more than one function. So like if you want to add several different functions to this, you just use add dynamic again. So we're just adding delegates at this point. I don't think C++ even supports delegates normally, but the guys at Unreal include that for you. Rotatable on anim triggered. There you go. Last thing we're going to do is make the trigger attach to the mesh. So attach to rotatable mesh, and then we need to say if attachment transform rules. And then we'll just use the including scale one, I guess. Actually, we'll do not including scale. Cool. We'll also quickly create a definition of this. Oh, these two functions here. So create definition. And then wait for this to load. Come on. Come on. Come on, IntelliSense. Really? Is it gonna do it? No. Damn it, IntelliSense. I know there's a way to fix that. I think someone told me in a video how to fix that, and I was like, I don't need that, but you waste so much time waiting for IntelliSense sometimes. Okay, anyways, so we're on the home stretch now. There's not much more code to write. The real great thing about this code we're writing is that you just write it once, and then we can reuse it so many times. That's the beauty of it. So we're going to go ahead and see if our animation curve is actually there. So I hope you guys actually set it up. But if you didn't, we're checking if it's there now anyway. If on timeline float. Progress function. So this is a delegate again. And the idea with this delegate is that we're basically assigning a function to this here to deal with the animation. So you actually need a function to handle the animation, but that's quite easy. And this is the function we're binding right now. So we say progress function dot bind to function, and then we simply say this and then pass in the name of the function. You can't actually pass in the function itself for some reason. You type in the name of the function, which is a little bit weird. But, yeah. My timeline dot add interpolated float. And then finally, we're going to set looping to false. Now, you might want to set looping to true if you want it to just loop forever. But in this case, we're going to set it to false. Because remember, the door only opens once. It's not infinitely opening and closing. Although there are situations where you might want that. Like, for example, maybe an elevator. You want it to always be going up and down. You know, maybe you're making a game and players can step onto this elevator and it's always running to take players to the top floor or whatever. You'd want to set it to loop so that the elevator is always going up and down. Okay. Set the initial rotation. You guys have no idea how close I have come to sneezing throughout this tutorial. I think I've only sneezed once, which is a really good effort, but I have come close to sneezing like 20 times. If you see my face, like, that means I'm like probably fighting off the urge to sneeze. The last thing we need to do is, because we're making it customizable, we need to actually check what the rotation is. So we're just going to use a little else if here. So if rotation axis equals your, else if rotation axis equals pitch, and then finally we need to check if it's roll as well. Again, this might seem annoying, but we only write this once ever, and then it's done. So put in roll, and then we're going to say target rotation dot your plus equals max spin, or is it max rotation? There it is. So we're setting the rotation now, or pitch. You may even want to write more functionality later on, where you actually customize all three. So you might want it to swing open diagonally. In that case, you would be doing like yaw and pitch in that example. So yeah, you could do that. that would work. That'd actually be quite cool. Inside of tick, you want to call handle progress. And then just pass in delta time. Handle progress is really easy. We're just gonna get a new rotation. Set it equal to fmath linear interpolate. So we're going between these two values using delta time. Very important that we use delta time so that we don't get any weird frame rate things where the animation goes faster on some machines. Then finally, on anim triggered, we're just going to check if the animation's playing. So if the animation isn't playing, then start the animation. But if the animation's already playing, so if the door's already opening, then there's no point playing it from the start. Otherwise, our door's just going to look really glitchy and weird. That's actually a problem that I had at the start. And there you guys go. That's it. I think. Is that it? I think it is. Let's go compile, and we'll see if it works. I sincerely apologize for that noise. I'll probably edit that out. If I don't edit that out, I'm sorry. Cool, so it compiled anyway. So we should be able to... So here's the beauty of it, right? Whenever we want something to rotate, we just create a blueprint of it. So you just go create blueprint class. I'm going to put it in this blueprints folder. We'll call it BP underscore rotatable. And I'm going to call this one glass door. So I want a rotating glass door. And to set up my door, I just go into the mesh here. We're going to set... I think it's wall door. Is the no? Oh god. It's definitely not that. Glass. You know what? Glass window works, I guess. And then we can move this trigger for the glass door. Go ahead and move this into the right spot. Stretch it out a little bit. Oh man, I'm so sorry. I'm not going to stop doing these videos even if I'm sneezing or dying or whatever it is. Anyways, we're going to set up the values for this now. So in this case, I'm going to make it rotate 90 degrees. And I'm going to make it rotate on the roll side. So float linear. And then I'm going to change this to roll. You could also change your code to make it so that it's not case sensitive. In this case it is case sensitive. You need to enter roll correctly. We'll compile and save that. And now when I drag this rotatable glass door into my scene, we should get this really cool looking effect where the glass slides out of the way. So let's try it out. Really? Really, dog? Are you serious right now? Is it just not doing anything? What the hell? Well, that sucks. That's not a very good glass door, is it? Alright, I'll be back. I'll just figure this out really quickly. Okay, so the problem is that I was calling handle progress. You actually want to call my timeline.tickTimeline. That's the proper way to call the animation handler. You shouldn't actually call it directly. So you go tick timeline, and if that didn't fix it, I'm gonna look really stupid. But I'm almost certain that's the issue. So I'll try that. What? What? It worked. Yay. Let's see. Change that. We'll go roll this time. Because I think that's going to look way cooler. Dude! Look at that. That's so cool. That shadow's a little bit weird, but we'll just ignore that for now. What would that look like if I put it in the doorway? Oh crap. The tutorial's pretty much over, by the way, guys. I'm just messing around at this point, but I wanna try this out anyway. Delete that. We're creating like, these are like the sort of doors they would have in the movie Men in Black. Stretch that out a bit. Did I do it? We're just gonna assume I did it. Let's see how that looks. Oh, dude, that's so sick. Am I the only one that doesn't? I think that's really cool. Anyways, that's it, guys. Animations. If you want to make a movable and scalable as well as a rotatable, just follow the steps that I showed you in this video, except instead of using F rotator, use F vector, and you're basically away. So anyways, I'll see you guys in the next video. This is my thumb. And yeah, I don't know what I'll do in the next one, but anyways, enjoy. See you guys later.